Yeah.
It's been so loud when I ask a question, so everyone knows.
Your legacy's gonna live on when this video is shown next year and the next year. Okay, so the first thing is, if I had enough, I owe you guys a bunch of Jolly Ranchers because I made a typo. We're talking about geometric sequences here, and the very first thing I wrote was arithmetic sequences. So would you cross arithmetic sequences out? We're not talking about those. We are talking about geometric sequences today. Okay, so geometric sequences are separated with a ratio, okay? So they are a sequence in which the ratio between each successive terms is constant, okay? And if you want to think of that as multiplication between the terms. So when I refer to the word a common ratio, with which we were using D for common difference before, you'll see me use the letter R today for common ratio. It's just that constant ratio that you see separating the terms. Like what are you multiplying by to get the next term? That's what I'm referring to when I'm talking about the constant ratio. Okay. So an example of something like this would be, for instance, like 10, 5, 5 over 2, 5 over 4. Can anybody tell me what's going on here? They're being cut in half. So you could say they're being multiplied by 0.5 if you want, or the fraction 1/2. These are being multiplied by the same thing each time. So sometimes the constant ratio is going to grow or be multiplied by a number bigger than 1. And sometimes it's going to get smaller, like if I'm multiplying by a number that's between 0 and 1. Okay, so the explicit formula actually is exponential. I don't know if you remember this, but when we graphed exponential functions, we multiplied the points to find them. So the explicit formula looks like this. To find the nth term, so a sub n equals, we take the first term, which is a sub 1, and we multiply by the common ratio to the n minus 1 power. The things that you're actually going to put in are, you're going to actually put in a sub 1. What are we going to put in there? Yep, a sub 1 is the first term. And the other thing you're going to put in here is R. And R is that common ratio. Okay. So what I want to point out to you is something interesting. So I want to point out that this is not an n. Do you notice it's an n minus 1? Okay, and here's why. Don't we already know what the first term is? Yeah, so we need to make sure we start this at n minus 1. So, because we're basically starting something that's exponential, which normally was at 0, and we're shifting it to 1 because it's its first term. That's the way I explain this. But this is always n minus 1 when we're doing these problems. Just be careful of that. All right, our recursive formula looks very similar to before. It's going to be 2 parts. You're going to define what a sub 1 is, and you're going to put the first term in. And then we're going to say a sub n equals a sub n minus 1. And notice that this part is the same so far. But instead of adding the common difference, we're going to write times r. Okay. So real quickly, what I want you to do is just with somebody around you, would you decide if these two sequences are geometric or not? And if you need to get a calculator out, like to divide the terms, to figure that out, then you can. Are those two geometric, yes or no? Just a yes or no is good enough. Okay, let's see. What do you think? What did you guys say?
First one, yes. Second one, no.
First one, yes. Second one, no. So what are we multiplying by to get the next term in this one? -3. Okay, so this is times -3, times -3, and so on. So this is a yes. Okay. If I did this one, 1 times 4 gives me 4, but 4 times 4 doesn't give me 9. This is interesting. These are actually squares. I don't know if you see those. 1 squared is 1, 2 squared. Yeah, but they're not geometric. Okay. So let's practice doing these. I think that since you guys have done explicit, I don't think I need to do both of these. Let's pick the one that's a little, maybe involves a fraction, since we always need work with fractions, okay? Let's pick to do this one. So I ask you to write the rule for the nth term of the sequence, both recursive and explicit, and then find the 12th term. Okay, so I'm going to pause a second. Especially for geometric, we sometimes get rather large things. So would you make sure you have a calculator handy, and if you need to grab one for my caddy, grab one a second. All right, so the very first thing I notice is that the first term is -15, which I'm definitely going to need. That's my a sub 1. The next thing I need you to figure out for me, guys, is what is the multiplier in this situation? So we go from -15, then to -5, to -5/3, to -5/9. Jones? Yeah, so in your head, if you were like, hey, I see that they're divided by 3, very nice, Jones says they're multiplied by 1/3 then. Divided by 3 is the same thing as multiplied by 1/3. All right, so I look up above, and I've identified those things. So here's how we write our explicit formula. We're going to put our things that we identified into our boxes for a sub 1 and r, and these a sub n and n minus 1 are always going to stay in there. So I write a sub n equals -15, and because 1/3 is a fraction, I'm going to put it in a parentheses, times 1/3 to the n minus 1. And then my recursive, that's explicit, is a sub 1 equals -15, and a sub n equals a sub n minus 1 times 1/3. All right, and finally we're going to get our calculators out, and we're going to find the 12th term. And this is where I want to point out to you guys that if this is n, what do I need to put there? It's always going to be n minus 1. So even though I'm finding the 12th term, what am I putting in for the exponent? 12 minus 1 or 11. So what I'm going to type in my calculator is negative 15 times 1/3 to the 11th power. Let's do it. So we get a really, really small number. I'm going to write this in scientific notation. It's negative 8.4647, and this means times 10 to the negative 5th. So if you ever get an answer like that, that's what that means is 0.00005 zeros, but you can go ahead and write it in scientific notation. Did anybody get the decimal to show up on their calculator rather than the scientific? Then write it that way, okay? Either is fine when it's a real small value like that. Like you might have got negative 0.0000, did I say enough O's? Negative 847, okay? Okay. Then the last thing I want to talk about is, what do you do if you want to figure out or use terms in a sequence? And we talked about this earlier, but we literally plug them in. So let's practice doing this together. If I wanted to find the first 5 terms, do I really need to plug 1 in to figure out what the first term is? Do you remember where it is? It's just that 12 in there. But if you did, you'd get 12 times 1/3 to the 0, which is 12. All right, let's find a sub 2. This is 12 times 1/3 to the 2 minus 1. What's 2 minus 1? You can show me with fingers if you want. Thank you. And 12 times 1/3 is the same as 12 divided by 3, or 4. A sub 3 is 12 times 1/3 squared. Okay, here's what I'm going to say about these. If I know that this is 12 and this is 4, and they're being multiplied by 1/3, right? If you want, you can just use the sequence down here at this point. 4 times 1/3 is 4/3, okay? What you would get here is 12/9, but that reduces to 4/3. What if you multiplied 4/3 times 1/3? What would you get? 4/9. And 4/9 times 1/3 would be 4/27. Okay.